Okay, so this is 7, 5. And again, we're going to talk about matrix operations. Okay, so some of this we're going to do by hand because it's faster. And some of it we're going to use a calculator because it's faster. So whatever method is quicker, that's the method we're going to choose. Okay? So, matrix addition. Here's the deal. You must have the same dimensions. And then all you do is combine matching elements. Okay, so we're going to do an example of this. Alright, let's say evaluate. And let's say we are given these two matrices, 4, -1, and 2, -3, plus 2, -1, and 0, 6. Okay, so first of all, just a recap of what we did yesterday. Let's talk about the dimensions here. Okay, so remember that when you describe the dimensions, you have to do row by column. So this is a 2 by 2, 2 rows by 2 columns. So this is a 2 by 2. And the only way you're allowed to add this to another matrix is if the matrix that you're adding it to is also a 2 by 2, which again, we have a 2 by 2 here, so we're good. So all you literally do is add the matching elements. So you're going to add the first row, the first column elements together. So 4 plus 2 is 6. And then -1 plus -1 is -2. And then 2 plus 0 is 2. And -3 plus 6 is 3. So far so good? Okay, good. Now, what if I put a subtraction sign there? Same thing, right? But you got to be careful because you could lose a negative. So just be careful with your negative. Do we have to do an example of that? Perfect. Moving on to the next operation. Scalar multiplication. Okay, so scalar multiplication is a number multiplied through a matrix. Okay, so if you have a scalar, you're going to see a number out front, okay, and then you just literally distribute it to every element. Okay, so let's say, we'll call this example 2. We'll use the same direction, evaluate. Let's say you had 2a. Okay, this is saying take 2 and multiply it through matrix A. So we got to be given a matrix. Let's say that A is 5, -2, 3, 4, and 0, 1. Okay, so 2A, you're just literally going to take 2 and multiply it by each element. So does dimension matter here? No, because it doesn't matter how many elements you have as long as you multiply them all by 2, right? So you can get 10, -4, 6, 8, 0, and 2. And that is 2A. Now this is real easy, right? It's going to stay this easy, but it's simple to make a mistake, right? Like you could add wrong, you could multiply wrong, so just double check. Even if it's so easy, you know, you want to do it quick, just be a little bit slow and check your work. All right, let's say, let's see if we, yeah, I don't think I can fit this here. I'm going to turn the page. Let's say I head this direction. Again, we'll just say evaluate. Given matrix A is this big guy. So -5, -2, 1, 0, 4, 0, -3, -1, 1. And matrix B is 3, 1, -2, -6, -2, 1, 1, 0, 4. what would you do if I asked you to find negative 2a minus b? So exactly, you got to follow order of operations, right? So you're going to do the scalar multiplication first, and then you're going to subtract matrix B from that. So let's do that. Let's find negative 2a first. So I'm going to take every element in A and multiply it by negative 2. Okay, so there's my negative 2a. And now I'm going to subtract b from it. So b is going to stay the same. Notice that in order to subtract, you have to have exactly the same dimensions. And the dimensions here are 3 by 3 in both of these matrices. Everyone okay so far? I know we're going a little bit quick. Do you want me to slow down a little? Everyone okay? Yeah, right.
The negatives that you have on the right side, those are going to become positive right here.
Yeah, exactly. So now I'm going to subtract. So I got to remember I'm subtracting this. If you want, you can change this to addition and distribute a negative sign all the way through your matrix so you don't lose it. It's up to you. Okay, so negative 2a minus b is going to look like 10 minus 3, so 7. 4 minus 1. Why don't you do it? I'll do it. We'll compare. Okay. How'd you do? So far so good. Any questions before we move on to the next one? Okay. All right, the next thing we're going to do is solve a matrix equation. Okay? Sounds complicated. Okay, so let's say we were given these two matrices. A is going to be a 3 by 2, so 0, 3, 2, 0, negative 4, negative 1. Everybody agree this is a 3 by 2? 3 rows by 2 columns. Matrix B is also going to be a 3 by 2. It's negative 4, negative 8, negative 12, 0, 14, negative 6. I guess we'll just call this example 4. We're going to solve for x. So let's say we were given 2x minus 2a equals b. Notice the capital letters. Okay, that is insinuating that these are matrices that we're talking about. Okay, so if I want to solve for x, normally, let's pretend like I wasn't even talking about matrices. Well, how would you solve for x? Get it alone, right? So add over the 2a, divide by the 2. So x would be a plus 1/2 of b. Agree? Okay, so you get x alone. That's step 1. Now, isn't that exactly what we just did? Right? Take a, which was, I'm going to put it down here. 0, 3, 2, 0, minus 4, minus 1. And then add 1/2 of b. So don't I have to distribute a half through b first before I can add these together? So if I distribute that half, this represents 1/2 b. I get negative 2, negative 4, negative 6, 0, 7, negative 3. Okay, and then you add them together. So negative 2, negative 1, negative 4, 0, 3, and negative 4. Okay. So notice that X is not a value, right? It's now a matrix. Any questions? One more thing. All right, the last operation we have to talk about is multiplication. So matrix multiplication. All right, so in order to multiply, A times B, the dimensions must be an m by n times an n pi p. Okay, so what's going to happen, here's the deal. These have to match. If they don't match, you cannot multiply. So the column in the first one has to match the number of rows in the second. If not, you cannot multiply. So these must match. Okay? Now, once you multiply them, the result is an M by P matrix. Okay? So like for example, you could take a 3 by 2 and multiply it by a 2 by 3 because the 2's match, right? And then it would result in a 3 by 3 matrix. Okay, does that make sense? That is the key to multiplication. If they don't match, there is no solution. It's not possible. Okay? All right. So let's say, I guess let's do example 5. Here's our two matrices. Matrix A is going to be a 3 by 2. So -4, -1, 2, 0, and 3, 1. And matrix B is going to be a 2 by 2 matrix, 1, -2, and 0, 7. Okay, I'm going to make a note of the dimensions. So this is a 3 by 2, and this is a 2 by 2. Okay, if I asked you to find B times A, the first thing you do, regardless of what you want to do with the calculator, okay, you got to check to see if it's even allowed first, okay, so you got to check to do the dimensions match up. So let's do that. So this is going to be a 2 by 2 because B has to come first, right, times a 3 by 2. So is this possible? No. So this is not possible. There is no solution to this. You're done. Okay, because these don't match. Alright? So it's like a little gift if you're given a problem like that because there's nothing to do. You're done. Alright? Now, if you were given A times B, okay, so now the order is different. Okay, it's not like real multiplication, right? If you take 2 and multiply by 3, it's the same as if you take 3 and multiply by 2, right? That's not true for matrices. So you got to really check those dimensions. So A is a 3 by 2, and we're going to multiply it by a 2 by 2. So are we allowed to do this? Yeah. So this is good. This is a good multiplication problem. Now this is going to result in a 3 by 2 matrix. Okay, so that's the type of result we're expecting to get. Now, in order to multiply, there are a lot of steps. Okay, I could show it to you by hand, but I'm not going to make you do it by hand. Okay, because it takes too long. So get your calculator out, and I'll show you how to do it. So you're going to type in matrix A. Now remember, if you'd like to clear out what you did yesterday, you can. Or you can just go back into your matrix menu, and when you edit, you can either choose to edit, you know, the matrices, you know, C through whatever, or you can just edit over A, which is what I'm going to do. So I'm going to choose A, and this time A is a 3 by 2. And notice that that changes the look of the matrix because the dimensions just changed. And then I'm going to type in my new matrix A. Be careful, double check your work. Second matrix, it's the inverse key, and then go to edit, and then type in your dimensions, 3 by 2. And then you can just type in each element hitting enter. Okay, so now we're going to do the same thing but for B. So second matrix, edit, arrow down to B. This is now a 2 by 2, and it was 1, -2, 0, and 7. Okay. Now, quit out of that, go back to your home screen. And then you got to tell it what you want it to do. You want it to take A and multiply it by B. So matrix A times matrix B. And there's your solution. Okay, everyone take a second. Make sure you can get this in the calculator. Do you need any help? Does anyone need any help on their calculator? Okay, so you gotta just quit out of it. Well, I am quit out of it here. Quit out of it. Go back into your matrix menu, and then you want names now. So you're gonna recall matrix A. Go back into the matrix menu and recall matrix B. Now, I want you to try to do B times A in the calculator and see what it says. It says dimension mismatch. So even if you weren't sure, the calculator will tell you, like, you're not allowed to do this. Stop. Okay? Sound good? This was like showing you the B times A. Right? What it would say. Okay? Now, I'm going to show you how you multiply by hand. I'm just going to show you this so you have an idea of what the calculator is doing. In order to multiply by hand, you're going to take this row and basically combine it with this column. So it's like you got to do -4 times 1 and -1 times 0, and then you add those together. Then you go to the next row, 2 times 1 and 0 times 0, and you add them together. And then you have to do 3 times 1 and 1 times 0 and add them together. So this is a lot of work by hand, especially if the dimensions were bigger, right? So we're going to use the calculator. Now, we could also go through and we could, add and subtract on the calculator as well, like we did. You could do scalar multiplication if you wanted, but that takes a lot longer, in my opinion, to enter all that into the calculator rather than just add numbers, right? So multiplication is a time saver with the calculator, and that's why we're going to use it. Sound good? Any questions?